Welcome back. Let's continue our discussion on domain and range. Let's look at the first problem. The first problem says, what is the domain of a given function? Okay, for a x value to be a domain of the function, the denominator cannot be equal to 0 if for a specific value of an x. Okay, so how do we do it? So let's continue. F of x equals x plus 6 over x plus 3 whole squared, right? X plus 3 whole squared equals 0. So x plus 3 times x plus 3 equals 0. So x equals -3. If x equals -3, then the denominator becomes a 0. So x cannot be a function of, x cannot be a domain, sorry, x cannot be a domain of the function, right? Of the function f of x. Okay, therefore x can be a domain of the function f of x for all real numbers except x is not equal to -3. So that is the correct answer. Okay, you can say all real numbers is a starting point, but it seems it's incomplete. It needs to have something else if it were to be a correct answer. 3 will not make the denominator 0, so anything with 3 is also incorrect. 0 will not make the denominator 0, so that's not possible either. If x is not equal to -3, then x can be a domain in the function f of x. Okay. If f of x equals x plus 3 whole squared divided by x minus 3 times x, if you just browse through the choices, you see 3 numbers, 0, 1, and 3. Okay, let's write the function f of x equals x plus 3 whole squared over x minus 3 times x. Let's substitute values of x of 0, 1, and 3 into this function. So x equals 0 implies f of 0 equals 0 plus 3 over 0 minus 3 times 0. The denominator is 0, therefore the function is undefined, right? X equals 1 implies f of 1 equals 1 plus 3 whole squared over 1 minus 3 times 1. Well, there's the function is defined. Similarly, x equals 3, f of 3 equals 3 plus 3 whole squared over 3 minus 3 times 3. The function is undefined. So x can be a domain of the function f of x if x is not equal to 0 and 3. Therefore, all real numbers of x such that x is not equal to 3 and 0 is the correct answer. Define a real valued function f of x equals 7 plus square root of 6x minus 17, right? Okay, if for, let's assume some values to really be able to explain this function. Okay, say if x equals 0, okay, that makes the term within the square root imaginary, right? Right? So the minimum value of the range cannot be 0. So this is out of the question. Okay. X cannot be 0. So anything with 0 is not possible. We have this value here, 2, 5, 6. What is that? That is same as 12 plus 5 is 17 over 6, right? What if you substitute that in the expression? 6x minus 17 is same as 6 times 17 over 6 minus 17, square root of 0, that's a 0. So it's 7 plus 0 equals 7. It's defined, right? So this is likely a choice. So anything with this 17 over 6 or above to infinity will keep the square root function a defined function and not an imaginary function. Okay, we can have negative here because say x equals -1. Okay, that means square root of 6 times -1 times -7 is square root of -6, -17 is -23. That's an imaginary function, not a real function, right? So that means negative is not allowed. So this is not correct. What if you choose 7? Okay, so if you choose 7, okay, if x equals 7, okay, that is 42 minus 17. That is also will result in a defined function, right? Right? But this is the minimum, right? When you substitute 2 5 over 6, the value inside the square is 0, whereas here it's, what is it, 25? 42 minus 17 is square root of 25, which is 5, right? Here it's 0, here it's 5. So these are both correct. The only problem is this, if you substitute 7, the minimum value you can have is 7 total. Here it'll be 7 plus 5, which is 12, which means if you can find a value that's even smaller by substituting something, then that's what would give you the range, the lowest end of the range, which means 7 is likely an answer, but 2/5 5 over 6 gives you even a smaller value. So this is likely the range. Okay. You see, 7 gives you a minimum total value of 12, whereas 2 5 over 6 gives you 7, right? 7 is less than 2, which means you want the range to have a minimum value and a maximum value. If x is 7, your minimum is 12, whereas if your x is 2 5 over 6, it's 7. Between 7 and 12, 7 is smaller, which means if you are lower end of the spectrum is 2 5 over 6, then that's where you end up getting a lowest value for this expression. So that is the correct answer. Okay, just like this one, f of x equals x and absolute value of 2x minus 7, restricting the domain to 0 to 10, give the range of f of x. So let's say f of x equals 0. Okay, the function itself is 0 because we want to find a value for x. Okay, that means 2x minus 7 equals 0, 2x equals 7, so x equals 3.5. Okay, now let's substitute all these values, x 3.5, x as 0, and x as 10 into the expression. So 2x minus 7, it's 2 times 3.5 minus 7 is 0, and 2 times 0 minus 7 is -7 equals 7. 2 times 10 minus 7 is 20 minus 7 is 13. So 13. So if you substitute 0, the minimum value possible in a range is 7. Whereas when you substitute 3.5, the minimum value obtained is 0. So the range is 0 to 13. Okay, don't confuse the x and the range. This is a range. The question is asking for range. What is the lowest value and what is the maximum value? Maximum value possible is 13, minimum value possible is 0. So the range is 0 to 13, and that is the correct answer. Okay. What is the domain of the function f of x equals square root of x plus 9? Okay, I can see three values, 9, f of 9, f of -3, and f of -9, right? If you substitute, say, x equals -3, then f of -3 equals -3 plus 9 is √6, right? And f of 9 is obviously x equals 9, f of 9 equals square root of 18. Whereas x equals -9, f of -9 equals square root of 0 equals 0, right? That means when f of 9 equals 0, that's the minimum possible value you can have, right? That means if you substitute any value less than -9, see, all of these are real numbers, right? Whereas if you substitute -10, that's the first time this becomes an imaginary value, right? This is I, right? It's imaginary. That means any value that's greater than or equal to -9 is going to define x as a domain in the function f of x. So this is the correct answer. Keep in mind, if the number is greater than -9, it's -8, -7, -6, -5, -4, and so on. Okay, this is the last problem in this video. I think I have one more video on the topic of domain and range. So without further delay, let's wrap this problem up. So we have a function f of x equals 1 over x cubed minus x. Okay, if you substitute x equals 0, f of 0 would be 1 over 0 is 0, it's undefined, right? X equals 1, f of 1 equals 1 over 1 minus 1 is 0. Again, it's undefined. X equals -1, f of 1 -1 equals 1 over -1 cubed. Negative of -1 is 1 over -1 plus 1 is 1 over 0. Again, it's undefined. So x can be a domain of the function f of x for all real numbers except -1, 0, and 1. All right, good. So if you've learned something, consider subscribing to my channel. And if you like my content, please share the content with your family and friends. And please stay tuned for the final video on the topic of domain and range. I'll see you soon.